Okay, this is going to be the review video, the final one for pre-calc for the trig graphs. We're going to go ahead and start with, I'm going to rewrite this for cosine. Okay, what you're going to do with that is, with the plus 7 over here, you're going to take the inside, set it equal to 0, and solve it. So that'd be pi over 4. That's going to be important because that will be our first angle. Okay? Then what I'm going to do is I'm going to find the period, which is 2 pi divided by the number in front of x, which in this case is 4, which is pi over 2. I want to find the interval by taking the period and dividing by 4. So pi over 2 divided by 4, which is pi over 8. So that's how the graph will move. Okay? Now for cosine, the values would be 1, 0, negative 1, 0, 1. If I continue on for 2 periods, I just continue these down, okay? So what I want to do is, if I want to add that, what would make sense is to turn that into something like this. So if I add that, that would be 3, 4, 5, 6, 7, 8, 9, 10. Now some of those are going to reduce. This will not. This will be pi over 2. That will not. That will be 3 pi over 4. This will not. This will be 1 pi. This will be 9 pi over 8. This will be 5 pi over 4. Okay? So as I go to graph, and then with the values I want to multiply by 3 and add 7. So times 3 would be 3, add 7 would be 10. 0 and 7, negative 3 and 7 would be 4. All right, still 7, still 10, still 7, still 4, still 7, still 10. Okay, all right. So when I go to make my graph, okay, all right, I'm going to make my graph. I'm going to start with pi's over 2. Cut those in half. Those will be my quarters. 5 quarters, 7 quarters. Cut those in half, so it gives you my eighths. So 1/8, okay, 3, 5, 7, 9, 11, 13, 15, okay? All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So at a quarter, I'm at 10. At 3/8, I'm at 7, so this is 10, 9, 8, 7, 6, 5, and 4. Okay, so 3/8, I'm here. At that, I'm here. At a half, I'm there. At 5/8, I'm back up at 7. At 3/4, I am up at 10. At 7/8, I'm at 7. At 1 pi, I'm at 4. Okay, at 9 pi over 8, I'm at 7. And then 5 pi over 4, I'm up at 10. That's what your graph would look like. Okay, all right. So what we have here, okay, from an amplitude standpoint, amplitude is just 3, that's that. My period, we found already, was pi over 2. Okay, my phase shift is this first thing, which was pi over 4. Okay, the domain, it goes on forever, so it's negative infinity to infinity. The range, it falls between 10 and 4, so it's just that. Okay, all right. Moving on to 2. Okay, 2 is slightly different. It is a secant graph. Okay, I'm going to rewrite this. Okay, by moving that 2 over to that side. Not a big deal. Okay, this is a little different in that we have to set, because of secant, we have to set that equal to negative pi over 2, which is negative 90. So if I add that, that'd be pi over 2 equals 30. Okay, or 1/2 x equals 30. And then if I cross multiply, x would be 60 degrees. Okay, so So that would be my starting point here, would be 60. Okay, now for my period, it would be 2 pi divided by 1/2, which is that number in front of x, which would give me, I'm sorry, not 2 pi, but 360, because we're working angles here. That would be 720 degrees would be the period. Okay, to get the interval, I take 720 divided by 4, which would give me 180. Okay, so that's how I'm going to work going all the way down. For as far as values go, for secant, we have undefined, 1, undefined, -1, undefined. That's the first part, just continue it off. 1, undefined, -1, undefined. Okay, so I'd add 180 to all these, so it'd be 240, 420, 600, 780, 960, 1140, 1320, and 1500. Okay, with the values, what I would do is I'm going to multiply by 3 and add 2. So it would be 3 plus 2 would be 5. -3 plus 2 would be -1. Same thing, 5, -1, pretty easy. Okay. Now, since you have a very big spread here, what I would do is I would just go ahead and move in increments of 180 degrees. It's going to make it easier. Okay, so I'm going to go 180, 360, 540, 720, 900, 1080, 1260, 1440, and then at the end here would be like 1620. Okay. So at 60 degrees, I'd be here, I'd be undefined. At 240, I'd be here, I'd be at 5. Okay, at 420, which would be here, I'd be undefined. At 600, I'd be at -1, which would be here. 780, I would be here. 960 would be into here, I would be up at 5. At 1140, I'd be undefined. At 1320, I'd be at -1. And at 1500, I'd be undefined. So the graph would look like this. Here, 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 and here. Okay? All right? So let's fill in some of this stuff. Amplitude is 3. Okay? The period was 720 degrees. My phase shift. Now, what you have to do with phase shift, because we set it to something different, if I would have set that equal to 0, that would have been 1/2 x equals 120, x would have been 240. That is actually my phase shift, is 240 degrees. Okay, my domain is all real numbers, okay, except x can't be. My first asymptote, whatever that is, plus my period divided by 2. So 720 divided by 2 would be 360n. The concept there is if I put in 1, that'd be 420. That's my next asymptote. Okay? All right, my range, okay, I go less than -1. So -infinity to -1 union. Okay, 5 to infinity. Okay, so secant's a little bit different. Okay? Secant's a little bit different. Okay? Let's go ahead and move on to number 3. Okay, video's still going good. Okay, so here's what we got for number 3. I got y equals 4. All right, cosecant theta minus 45 degrees plus 3. Okay, I'm going to take that inside. Theta minus 45 equals 0. Pretty easy. Theta equals 45. That's going to be my first angle over here. Okay, 45. Now, what's convenient about cosecant and secant is they have the same values, okay? So this is going to be undefined, 1, undefined, -1, undefined, 1, undefined, -1, undefined. Okay? All right? So what I want to do next, I want to figure out the period. So the period will be 360 degrees, okay? All right, divided by 1 in this case, which would be 360, okay? My interval will be 360 divided by 4, which gives me 90 degrees, okay? So that puts me at 135, 545, 315, 405, 495, 585, 675, and 765. Okay? Because of my values here, I'm going to take times 4 plus 3. So that would be 4 plus 3, which would be 7. That would be negative 4 plus 3, which would be negative 1 still. And this would be 7 and negative 1. Okay? All right. Not as big as a gap, but still a pretty good one. Okay? So what I'm going to do here, all right, I'm going to go ahead and start at 90, 180, 270, 360, 450, 540, 630, 720, and 810. Okay, all right. So at 45 degrees, which would be halfway here, I would be undefined. At 135, which is halfway there, I'd be at 7, 3, 4, 5, 6, and 7. 135 would be at 7. 225, I'm undefined. If you wanted to divide these out and figure out, they're all the 45s if you wanted to do that. If you really want to do that. We usually work in the radians, so if you want to do that, you can. Okay, you don't have to though, okay? All right, so 225, I'm undefined. At 315, I'm at negative 1. At 405, I'm undefined. Okay, at 495, which would be halfway here, I'm at 7. At 585, it's halfway here, I'm undefined. At 675, I'm at negative 1. And at 765, I am undefined. Boom, 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 boom. Okay, so to find the rest of this stuff here, all right, our amplitude is 4. Our period, which we figured out already, was 360. Okay, our phase shift was 45. Our domain is going to be all real numbers, except x can't be. 45 degrees, that's our first asymptote. And then I'm going to take my period and divide it by 2. So 360 divided by 2 would be 180 degrees with an n there. That's because if you total that up, you get 225. My range goes below negative 1. So negative infinity to negative 1. And it's a union with 7 to infinity because it goes above 7. Okay? All right, moving on. 2 more graphs. All right, 2 more graphs. I'm going to rewrite question 4. It's a cotangent one. I'm going to rewrite it to be 2 cotangent 2 theta plus pi equals 0. Oh, I'm sorry, minus 1. Okay, so cotangent, I'm going to set that 2 theta plus pi equaling 0. So 2 theta equals negative pi. Theta equals negative pi over 2. Okay, all right, so that will be my first angle. My values for cotangent are going to be undefined. 1, 0, negative 1, undefined. 1, 0, negative 1, undefined. Okay? What I want to do is take the period here, which is going to be a little bit different, is pi divided by the number that's in front of x or theta, which would be 2, so it's pi over 2. My interval will be pi over 2. It will be pi over 2 divided by 4, which would be pi over 8. Okay, all right, so very similar. What I want to do is make this into a common denominator, which is negative 4 pi over 8. Okay, all right, and then so I want to add a pi here, so that'd be negative 3 pi over 8, negative 2 pi over 8, negative pi over 8, and 0, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Now I'm going to look to reduce any of the fractions. That one will not reduce. This one will be negative pi over 4. This will not reduce. That will be 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. Okay? All right, what I want to do with the values here is times 2 minus 1. Okay, so it'd be 2 minus 1, which would be 1. It'd be 0 and negative 1. That would be negative 2, negative 3 now. Okay, all right, and the same thing. This would be 1, negative 1, negative 3. Okay, so since I go into the negative pi's, I'm going to have to, somewhat have a part on this side. So I want to go negative pi over 2 and pi over 2. And let's go pi. I think that's all I have to do. Okay, so if I cut that in half, okay, that would be negative 1/4, 1/4, 3/4. Cut that, I'd be negative 1/8, negative 3/8, 1/8, 3/8, 5/8, 7/8 if needed. Okay, all right. So at negative pi over 2, I'm going to be undefined. At negative 3 pi over 8, I'm going to be at 1. At negative pi over 4, I'm going to be at negative 1. And then at negative pi, I'm going to be negative 3. And at 0, I'm going to be undefined. At pi over 8, I'm going to be at 1. Pi over 4, I'm going to be at negative 1. 3 pi over 8, I'm going to be at negative 3. And then pi over 2, I'm undefined. So this is what your graph looks like. It's like a little chair. Okay. All right, that's what it looks like there. Okay, all right, so my amp will be 2. My period, which we found already, will be pi over 2. My phase shift is negative pi over 2. My domain is all real numbers except x can't be. My first asymptote, okay, and then what it's going to be for cotangent and tangent is just the period, okay? All right, so plus pi over 2, okay, times n, all right? Okay, if you apply the same concepts, that works. The range in this case, since it is a continuous function, will be negative infinity to infinity. Okay, all right, moving on to the last graph. We're still running here, that's great. Okay, I'm going to rewrite this function to make it easier for us. Okay, I'm going to go ahead and just so we have consistency here. All right, if it starts out like this, to make this easy, I'm just going to distribute this inside. So I got something that all that stuff is inside. So 1/2 x minus this would be pi over 6. Okay, if that helps you, run with that. Okay. So what I would do is take this, set it equal to 0, and solve. So it'd be 1/2 x equals pi over 6. Cross multiply would be 2 pi over 6. It's pi over 3. Okay, that's my first thing. All right. All right. So the values for sine are 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. Okay. What I want to do is take my period, which would be 360, divided by 1/2, because that's the number there. That'd be not 360, I'm sorry, 2 pi, divided by 1/2 would be 4 pi. Okay, would be 4 pi there. Okay, my interval will be 4 pi divided by 4, which would be 1 pi. Okay, so to figure this out, what I would want to do is basically I would want to add by 3 pi over 3 as if I was making a fraction. So it'd be 4 pi over 3. All right, so if I add basically 3 pi over 3, all right, that'd be 7 pi over 3, 10 pi over 3, 13 pi over 3, 16 pi over 3, 19 pi over 3, 22 pi over 3, okay, 25 pi over 3. Now, what is that really? If you divide that, that's about 8 pi. So I'm going to work in increments of pi is probably going to be the best way to do it. Now for my values, what I want to do is I'm just going to multiply that by 2. Okay, so that's going to give me 0, 2, 0, negative 2, 0, 2, 0, negative 2, 0. Okay, I don't use those anymore. All right. All right, so since it's so big, I'm just going to go in increments of pi. So I got 1 pi, 2, 3, 4, 5, 6, 7, 8, and then the last one we'll put 9 pi all the way out there. And if you look at that, 25 divided by 3 is 8 1/3. So, all right, so that's 1/3 pi, so that's going to be 0. 4/3 is a little bit more than 1, that's going to be up at 2. All right, 7/3 is a little more than 2, that would be at 0. 10/3 is a little more than 3, that would be at -2. 13/3 is a little bit more than 4, that's going to be at 0. 16/3 is 5 1/3, which would be here. 19/3 is a little more than 6, would be 0. 22 would be -2. Okay, and then 25/3 would be 0. Okay, so this is what my graph would look like. Okay, so my amp would be 2, my period would be 4 pi, my phase shift would be pi over 3, my my domain is -infinity to infinity, and my range, it goes from -2 to 2. Okay, all right, and we're going on to the last question. All right, last question, number 6. All right, says AB lies on the unit circle on the terminal side. So we got a point AB, and it's on pi over 12. All right, so what you have to look at is where would that be? Well, that's going to be in this quadrant. So let's assume A comma B. Okay. All right. So what the first question says is find the coordinates at theta equaling 13/12 pi. So at first I looked at what does that mean? Well, if I were to add pi to this, okay, and I did myself got myself a common denominator, that would be 13 pi over 12. That's what that it basically is. So what does that mean? If I add that, this would be basically down in this quadrant. Okay. So what would A be? Well, let's think about this. Down in this quadrant, the first value is negative, and the second value is negative. All right. So this would be negative A and negative B. Okay. All right. To answer question B, it says, where is this negative A and B? Well, let's think about that. Where would that be? Well, that would be in this quadrant here. Okay. So I would have a negative A, so the x coordinate would be negative, this B coordinate, which would be y, would be positive. Okay. So how do we know this? This would be, all right, if I'm at pi, all right, this relationship is pi over 12. So if I do pi minus pi over 12, because remember, we always work to that, all right, that's 12 pi over 12, which would give me 11 pi over 12. So it's a little bit of a conceptual question, all right, really test your thinking on a number of different levels. So that is the exam review video. Hope you learned something this year. This trig stuff definitely will be important for you next year.